Let's now consider a power that is not a positive integer. Let's consider w equals z to the power minus 1, reciprocal. So w is 1 over z. This, like positive integer powers, is simplest in polar coordinates. So if z is r e to the I theta with minus pi less than theta less than or equal to pi, then 1 over z is 1 over r e to the I theta, which is 1 over r times e to the minus I theta. So the polar coordinate representation of w is going to have radius 1 over r, where r was the original one, and it's going to have angle minus theta. And there's a little bit of trickiness that's going to happen with the minus theta because of the change of the closure here. Okay, because when theta is pi here, minus theta will be minus pi, and that'll put the closure on the other side. So that's actually going to cause us a headache. But let's just draw a quick graph. So in the z plane, if we have a circle of radius 1, so we start here, really, there's a little gap there, and we go this direction, zoop all the way around. Then in the w plane, the radius is 1 again, because 1 over 1 is 1. But now we're going to be going in the other direction, because if theta is increasing here, then minus theta is decreasing. And we start just above pi, and we go around and we touch on pi here. So that's actually going to give us a headache on the negative real axis. But other than that, the reciprocal is fairly straightforward. So let's look at another. So that's radius 1. Let's look at another one. Let's decorate this with w plane. So now let's look at radius 2. Well, I want to start on the outside, but it's not true. The radius in the w plane is not 2, but 1/2. So I'm just going to put, that's radius 1/2 there. And a bigger circle at 2 million. Circle of radius 2 million. Obviously, it's not to scale here and going outside everything. Will be very, very tiny here, circling that way. So large circles in the z plane get mapped to small circles in the w plane. Likewise, small circles, so if we start at 1/3, here radius 1/3, and go around the circle, we will go from the top around here at radius 3. So this little circle gets mapped to a big circle over here. Very straightforward, but the direction has changed. So going this way in the z plane means we're going this way in the w plane, and that's just the change there. And the fact that we've closed things on the top here means we're closing on the top, but that changes to closing on the bottom here. And as I say, that's going to give us a headache. Going the other way. Oh, okay. So if we go the other way, it's very straightforward. So if we start with a value here, and we want to know which value over there gives it, we need to reciprocate the radius. No problem with that. And we have to negate the angle. But normally, if we're starting in this plane, we measure angles this way. And this is the headache. So anywhere except on that line, we're okay, because all we do is negate that angle, and that gives us the symmetric one over here. But if we're on the negative real axis, then we want to use the positive value of phi, because that's the way we're used to measuring things. And when we take the negative of it, oh, we're outside the range that's normally true here. So we have to be careful on this line, which is the negative real axis, with the closure. So bookkeeping is important when going backwards. The only other point of issue is what happens at 0. Well, at a really tiny thing here, we get mapped to a really large circle here. A really tiny circle here, we get mapped to a really large circle here. So it's natural to say 0 gets mapped to infinity, complex infinity being the circular infinity, and 0 here gets mapped to complex infinity there. So we include tagging 0 in the W plane with infinity in the Z plane, and 0 in the Z plane with infinity in the W plane.